started. If I was reading the website correctly, y'all do not have a lab tomorrow. Is that correct? You have a makeup lab if you need to make up a lab, but not a new lab. And does anyone know when y'all are scheduled to present your project? Is that next week?
December 5th, I think.
No, that's when the reports due. Well, it's different from when you present it.
No, I thought she said it was due the same day. I think it was due.
What day of the week is December 5th?
It's gonna be a Friday.
Yeah, so,
I think it's the third then. I think it's that week because we normally submit our lab reports the Friday of the week. I think it's the third then.
okay, so the Tuesday after Thanksgiving, which is not exam week, so probably the last Tuesday of the semester. So what that means is that we have, is next week Thanksgiving?
Yes.
Okay, so you have next week, and then you come back from Thanksgiving, and then it's due. And that's often how it is. And so the deal is, y'all are in good shape because you're here today, you're starting to think about it, you're gonna get going. Some people are not going to think about it until Thanksgiving break, and then there's really not enough time to work on it just over Thanksgiving break. Now, I usually am around that Monday and that weekend before if people want to come in and test their project. I have a basis board that you can test it on, and you can compile your code and see how it works. If you want to, I'll probably have that set up. But you don't want to wait until the last minute because I have not ever seen that go well. So let's talk a little bit about the lab project and get some ideas about how to go about it. So who has read it? Yeah, anyone? Yeah, all right. Anyone else? Okay, okay, so you've all read it. All right, so what's the basic idea behind the project?
Kind of simulating an elevator, and then whatever input you put is supposed to go to that floor, and then the reset it. It's kind of like a
Does it have a reset? I don't think it has a reset.
yeah.
Some years it does. Yeah, this year there's not a reset. Yeah, and you do want to be careful because it's not always, there have been elevator projects before, they're not always exactly the same. So, do be aware of that. Yeah, okay, so, but there are some other requirements too. So there are switches that you would set, and there are, well, let's talk about the inputs and the outputs. So just to review, why don't y'all look over the inputs right here and make sure that we understand what they do, because I have found usually people have a little bit of misunderstanding, or some people have some misunderstanding about how the project is supposed to work. So what do the switches indicate?
Floors.
And what about the floors?
What do you mean?
It's getting called to that floor.
Yeah, it's getting called to that floor. So it's like not that it's on that floor, or even necessarily that it's going to that floor, but that someone has called it to that floor. Is there any restriction on which switches could be set? Like, is there any reason why they couldn't all be set?
No.
Yeah. Yeah. Okay, so there's no restrictions on that. So we have 4 switches. And I found it useful, and you may or may not find it useful. I think you probably will. To use one variable for the 4 switches And so, like I would say SW 3 comma 0, like that would be an input. So if I had that, that would mean that I have one variable that's 4 binary numbers that would indicate my 4 switches. And then I just have to decide how I want those to be assigned. So like if we're doing our constraints, I think it's useful to go ahead and decide how you're going to do this, because the inputs and outputs are going to be the easiest things. So we can go ahead and decide how we're going to do that. And if we look at the assignment, it says use switch 1 for the first floor, switch 2 for second floor, switch 3 for third floor, and switch 4 for the door blocked. So that is given to us. Just so you know, on one of my 2 basis boards, one of these LEDs is broken. And so if you're using my basis board to test it, if you use these exact ones, I think it's LED 8, I'll figure out which one it is. But just that, it'll seem like floor 2, if I remember correctly, which is LED 8. Like floor 2 will never light up because that LED is broken on one of my basis boards. But let's get the constraints for those switches. And those were switches 1, 2, 3, and 4. So because of that, and because I'm lazy, I'm just going to use this as my variable name, SW. That way I don't have to even change anything. And so I can see that SW1 is going to correspond to SW1 is going to correspond to the first floor being called, SW2 to the second floor, SW3 to the third floor, and SW4 for the door blocked. So rather than doing it like I said here, from 3 to 0, I'm going to make it 4 to 1, and that's just out of sheer laziness, so that way I don't have to change the constraints. But you can call it whatever you want. You don't have to use the same ones. And so this just means that in my code now, SW1 is the switch for first floor. And SW2 is the switch for second floor. And SW3 is the switch for third floor. And SW4 is the switch that indicates that the door is blocked. So that means that if we look at a value for SW, if SW equals 4B1001, what does that tell me about the state of the switches? What is that telling me?
Are the ones supposed to represent like what switches are on?
Well, yeah. So if I map these to switches, so if I do what I did here in these constraints, so I have switch SW1 is matched to this switch. What this means is I don't actually set it. I can't do this in the code. This is something that I would read, and so I would get the value of SW from the board, and the value of SW would tell me how the switches were set. So this would tell me that switch 1 was on, and switch 4 is on, and that switches 2 and 3 are off. And that's going to be really important, is being able to read the value of the switches. And so if we're having it as this one 4-bit variable, we have to be able to read the value of the switches to find out how it is, what's going on. And so what would we do, like if I wanted to have in my code, if I wanted to have something that was true if floor 2 is called. So if I wanted to have code that checked that, what would that code look like?
A multiplex?
That's what the circuit would look like, but I'm asking about the Verilog.
It would have an if statement.
I'd have an if statement, and what would I be checking in that if statement?
If SW2.
So I can just do plain if SW2, and then whatever, or I could do if SW2 equals 1, and those mean the same thing. Okay, so what would it mean if I said, if I had in my code, if if I had that, if not SW4, what does that do?
Checking if it's false.
If it's not blocked.
Mm-hmm. So if it's not blocked. If I do case SW, how many different cases am I going to have? It's more than 4. And that's because I can have more than one switch selected at a time.
Would it be double that?
And it's more than double.
4 times?
2 to the 4th.
Okay.
16. So I would have 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, and so forth. Now I'm going to show you how you can do don't cares in here so that you can like lump some together. Because like you might want to do the same thing if the door is blocked, no matter what the other switches are. Because if the door is blocked, can you go anywhere?
No.
No. So it doesn't matter what the other switches are. And so I'm going to show you how you can deal with that so you can condense, 4 states or 8 states into one when the door is locked. So I'll show you that. Okay. Let's talk about the outputs now. Okay, so let's look at our outputs. What are our outputs supposed to be?
They indicate where the elevator is at.
And also whether the door is open. And it says use LED 7, 8, 9, and 10. So I'll see that I am my usual lazy, and I will call this variable LED. And then I don't have to change that name either. So we have and these will be things that we set. LED 7 indicates that you're on floor 1. Not that floor 1 has been called, but that you're actually on floor 1. LED 8 indicates floor 2. LED 9 indicates floor 3. And LED 10 indicates door open. Now, are we going to see all 16 possibilities for these outputs? Yeah, why not?
Because it can't be on 2 floors at once.
Can't be on 2 floors at once. So how many different sets of outputs are we going to have? So
If the door's stuck open, would it still have would it still light up before it's on, so there'd be 2 lights on?
Yeah, I think so. So there are some things you could interpret, but I think that it has to always be on a floor. And so I don't think there's I mean, you could go all crazy, and there was someone last year who had so many different states, that including one for being stuck in between floors, but I don't think that's necessary. So I think you would have 2 possible states, or not states, these are outputs. These are not the same as states. You have 2 possible outputs that would correspond to being on floor 1. So, and this one would be LED 7, and this one is LED 10. So you'd be on floor 1 with the door closed, or on floor 1 with the door open.
So there's 6 possible outputs?
I think so. Let's see, because you would also have I think that's all you could have. I mean, I guess you could consider a reset state with everything 0, but I don't see that that really makes sense. I would think your reset, if your starting state, I think would be starting on floor 1, or you could have it start wherever you wanted, but it has to be somewhere. So I think those are the only possible outputs. Now, it would be nice if those corresponded to states, but they don't. So let's go back to this. Now let's think about what we have so far. And by the way, there are lots of ways to do this. Every semester, there are a lot of people who do things kind of the same way I do them, and a lot of people who go a different path, and there are lots of correct ways to do it. From experience, I know some things that work better than others, and I will give you all those tips as we go through. Okay, so what inputs and outputs do we have?
Clock, SW, and LED.
Clock, SW, LED. And that's it, right? Does Verilog have a semicolon at the end of that? I think it does. So input clock and input 4,1 SW. Output reg. (10:7) LED. Now, if you don't want to do that, if you want to have, if you don't want to have LED 7, LED 8, LED 9, LED 10, if you want to have 0, 1, 2, 3, 4, you certainly can define it that way. Now, why do you think I made it a reg?
It'll be changing constantly.
And it'll be changing in an always block. Because what is our general design for a finite state machine in Verilog?
To have shift registers? Or is that not correct?
That's kind of correct. But in a previous session, I said when you do a finite state machine in Verilog, pretty much always going to have a certain format. And I strongly, remember I said that I'd give you all some hints? I strongly, strongly recommend that you do this as a finite state machine. That's how the project is assigned. And that's what they mean for you to do. It's real tempting to think in terms of procedures and to think in terms of, well, if I do this, then the door opens. If I do this, I go to this floor. And to think in terms of procedures, because that's how you've written code before. That's really going to make everything a lot harder. If you just do this as a finite state machine and define your states, that part will be long and tedious, but once you have it set, the coding will be easy. And the coding is going to be, you'll have two always blocks. You'll have always at current state, and you'll have some stuff in here, and you will almost certainly have case current state, and you're going to have that always block, and you'll have another always block. Always at pos edge clock. And at the positive edge of the clock, that's going to be when you advance your state. So there's going to be other stuff in here, but this is your the main program for any finite state machine. Okay, so we've gone as far as we can go without figuring out what states we're going to have. So now it's time to think about the states. So, and this is going to be where y'all have some input, and we'll talk about it together, and whatever we come up with, this is what I'm going to go with for this year. So what do you think our states ought to be?
Is the way that it's set up, is that as a more machine?
Well, it doesn't say. So that's what. So let's decide that. Do we want to do melee or more? So, and what's the difference?
The state or the output changes with the state in the melee machine?
So with a more machine,
And
the output depends only on what state you're in. And with a melee machine, the output can depend on the inputs. And there's not really a correct answer here. It is also, if we have a more machine, it can also be useful to have another always block, always at current state begin and case current state. So in this always block, we would set our outputs, and in this always block, we would determine our next state. So a more machine usually ends up having more states, but it ends up being easier to understand. A melee machine tends to have fewer states, but it's a little harder to understand because the output doesn't necessarily match the state that you're in. With a more machine, the output would match the state that you're in. So how many outputs did we have?
6.
Yeah, we had 6 different outputs. So we know that that means that we are going to have at least 6 different states. Okay, so I need some ideas here. What should our different states be? What should the states indicate? Do we want the state to indicate what the output is to start off with?
Yeah, I feel like the state should indicate the 4, and then the state should indicate whether 4 is
Okay, so in other words, that would be indicating the outputs. So indicating outputs, floor and door open or not. So if that's all we had, then we would have 6 different states. And is that going to be enough? Because we have to figure out how to go from one state to another. Okay, so this is where we need to go back and look at our project and what the specifications were. Okay, so let's look at, so I need y'all to read these or reread them and see if that gives you any ideas as to what else we might need.
We have to have a state for when it's moving too? Or do we not?
That's something to think about.
Do we have a state for the door to stay open for 2 clock cycles?
Okay, so what does that really mean, a state for the door to stay open for 2 clock cycles? I get what you're saying, and you're right, we have to figure that out. So,
A
yeah,
rest state, I guess.
okay,
A rest state while the door's open.
okay,
Can you like multi-purpose the rest state for like there being no inputs and then also for when the door's open?
we can. So it'd be different inputs will go along, so we will have, like, in the worst possible scenario, we would have there were 16 different possible inputs that we would have for each state. We'd have 16 different possibilities for where it's going. We don't want that at all. So what you're saying is, can we, multi-purpose some of those, and we can do that, yeah. Okay, well, let's think about it. We know we need to at least have the following, and I'm not going to give these names yet. I'll just say floor 1, door closed. Floor 1, door open. So these are our 6 different outputs that we came up with. Floor 2, door open. We may have to put some more stuff in these descriptions, so I didn't really make these big enough, so hold on. I'm going to redraw these. We need floor 2, door closed. Floor 2, door open. Now, there are other ways of doing this. This way, though, this will be, by doing it this way, we know what the output is on each of these. So floor 3, door closed. And floor 3, door open. So we know already the output on each of these. We know the output would be, for this one, the output would be 0, 0, 0, 1. And here the output would be 1, 0, 0, 1. And what would the output be for floor 2, door closed?
0, 0, 1, 0.
And floor 2, door open?
1, 0, 1, 0.
And floor 3, door closed?
0, 1, 0, 0.
And floor 3, door open.
1, 1, 0, 0.
Okay, so we already know the output for those states. But now we have to figure out the state transitions. How do we go from one state to the next? And that depends on the inputs. So let's say I'm on floor 1 with the door closed. Does that tell me, have I necessarily already been there for the required number of clock cycles? Like, if I'm on floor 1 with the door closed, am I ready to go on to another floor? Let's take a look at what it says here. If someone presses the first floor button, the elevator should go to that floor, open the door, and remain on this floor with the door open for a small amount of time, then close the door. Assume the elevator takes 1 clock cycle to travel from one floor to an adjacent floor, and the door stays open for 2 clock cycles. So if the door is closed,
That means you're waiting for a clock cycle before moving on.
The doors stay open for 2 cycles?
the doors stay open for 2 cycles. But if nothing happens, then the doors close. So like, if you're on floor 1, if you go to floor 1, the doors are open, and then they stay open for another clock cycle. And then if you don't go anywhere, the doors close and you stay on floor 1. If you go somewhere, the doors close and you go somewhere.
So basically it's starting at its rest.
Yeah. So I'm not saying it's starting there, I'm saying I am there, and I'm saying that is a rest state. So any of the floors with the door closed is a rest state. That means you have already gone through the process of having the doors open for a certain number of clock cycles, because you can't get to the door closed state without having already had the door open. Because presumably the doors will be open when you arrive at a floor, because you don't want to wait an extra clock cycle for the doors to open. So when you get to floor 1, so when you first arrive at floor 1, that state is going to have the doors open. So let's think about our possible inputs and what would we do for our inputs for floor 1. So if we're on floor 1 with the door closed, what happens if the door blocked switch gets pressed? What does it say happens with that?
The door's closed, so
Yeah, it doesn't seem like it would be relevant, right? Yeah, so it seems like that one is a don't care, really. So here, we're going to look at our possible inputs. Our door blocked input is a don't care. So our possible inputs from here are don't care, 1, 1, 1. Don't care. I'm going to write this somewhere else. So inputs from floor 1, door closed. Door's already closed, so it can't be blocked. So we have a don't care, and then we could have all 3 switches pressed. We could have a don't care and 2 and 3 and not 1. We could have 1 and 3. We could have none of them. We could have 1 and 2. We could have just 2. We could have just 3. We could have just 1. And those are all the possibilities for the inputs. So what does it mean if our inputs, if these are our inputs? What does that mean?
Getting called to floor 1,
Yeah, and where is it?
already on floor 1,
Already on floor 1.
so it just means the door open.
That's the way I would take it. Yeah. They would just go to the door open state. As a matter of fact, I would do that. I would do that for any of these, that if floor 1 is called and I'm on floor 1, I would open up the door. What do y'all think about that? Not everybody agrees with me on that.
Does it matter like what input comes in first, or is it just okay?
There's no timing involved. It's going to look at all of the inputs at once, and there's no memory of past things. It's whatever they are right now. So it's going to look at them right now, and if 1 is pressed, to me it makes sense to open up floor 1. Other people have told me in the past, like, well, they're already on floor 1. They should have gotten off if they wanted to get off before. It doesn't really matter. You just have to be able to explain it when you present your project, what you're doing. But to me, it makes sense that if 1 is selected, it should go to the state with the door open, no matter what else is going on. So I would do this, where I would have don't care, don't care, don't care, 1 would take me to that state, floor 1 with the door open. Okay, let's look at our other possible inputs. So we've taken care of 4 of our 8. And we have 8 instead of 16 because we put a don't care for the door blocked. Okay, let's look at this one right here. What about none of the switches? What do we want to do with none of the switches?
Just stays.
Yeah, that one makes sense that we would just stay. So we would have don't care 0, 0, 0. Okay, now we have 3 more states to look at. We have the state where just 3 is selected. where just 2 is selected and where 2 and 3 are selected. Where do we want to go if just 2 is selected?
Floor 2 door open.
Floor 2 door open. I'm going to wait a minute to fill this in because I might have another don't care in here. This is definitely going to be D010. But do we want to go to floor 2 door open if we also have 110? If 2 and 3 are selected?
Yes.
Yeah. Because if 2 and 3 are selected and I'm going to floor 2, I'm gonna be pretty mad if we go through floor 2 and go up to floor 3 without stopping on floor 2. So we'll go there. What about if just floor 3 is selected?
Floor 3 door open.
That's what I used to do, but then someone pointed out to me that assume the elevator takes 1 clock cycle to travel from one floor to the adjacent floor. In 1 year, one of the lab TAs did take off because the elevator magically went from floor 1 to floor 3 without going through floor 2.
So if it's D10, it has to go to door closed for floor 2, then floor 3.
But then is that not a different state?
It might be, we don't know yet. We need to keep that in mind. It might end up being a different state. Right now, we can put it here and we'll see, does it need to be a different state? So we'll just have like a question mark here. Does this need to be a different state? And I'm not sure it does, because once you're on floor 2 with the door closed, if you leave the switches the same way and it's still on selected for 3, I don't see why you wouldn't just go on to 3 from floor 2 door closed. But we'll keep that in mind. We'll see what goes on from there. Okay, so our only question now is that 3rd floor. So we took care of all of our transitions from floor 1 door closed. But now we got to go to floor 1 door open. And there's a difficulty because when you first arrive at a floor, you have to stay there for 2 clock cycles before you can do anything. So I think what has to happen when you get to floor 1 door open is that the door has to stay open for 2 clock cycles. So I think for 1 clock cycle you can't do anything at all. So I think you have to have another state. And wouldn't that be true, like, no matter what the switches were?
Yes.
I think so. Okay, so once you're here and you've gone to your second clock cycle, now you could go to any other floor. So you could do all the same stuff that you did from floor 1, door closed. Right?
You won't.
I think you would stay open for 2 cycles for all 3 floors.
What's that?
Like for all 3 floors, you would stay open for 2 cycles.
Mm-hmm. So are you saying we needed another one for all 3 floors? Yeah,
I
yeah.
think so.
yeah, we will. But I think you were gonna say something else.
I mean, from this state, you won't ever, like, you won't go, like, from the second cycle, the only thing, you can't go to a floor 2 closed door, you can only go back to a floor 1 closed door?
I can go to floor 2 door open. I could go to floor 2 door closed. I could go to floor 1 door closed.
Straight from the first door open second clock cycle?
Yeah, because we're not, if we start making the door opening and closing a clock cycle, then we're adding an extra clock cycle in there. If we're just saying it remains open for 2 clock cycles, these are our 2 clock cycles, and it's going to be closed as it goes between floors. You don't have to put in an extra clock cycle for it to close in between. And this is at least the way I had it explained to me. We know that in reality, the door closes when you go from floor 1 to floor 2 and then opens back up. But we are just going to say that happens during the transition, and we're not adding an extra clock cycle for that.
And what I'm saying is, so say we have 0, oh no, alright, never mind, I get it. Because my thought was, so say if it's called to the second floor, it's not gonna remain closed, but if it's called to the third floor and not the second floor, it's gotta go door closed.
Right. Yeah. Okay. What if you do nothing?
And door closed.
Go back to floor 1 door 2.
Yeah. What if the door is blocked?
Stay open.
Will it stay in this state right here?
They go back to itself. Can the door open 2 clock cycles?
That's the way I would do it, but I think it's open to interpretation. So what do y'all think?
Well, if it's blocked open, would it have to go through another 2 clock cycles?
It doesn't say it does.
I don't think it would stay.
So that makes me wonder about. No, I like that one. So I think it would be this. So I think this would be 1 and don't care, don't care, don't care.
But then you would have 2 more, I guess, or inputs that would be like 0, 0, like, or 0, 0, 1, 0 to
Yeah.
get to the next one.
Yeah, so what you have to be aware of whenever you're doing this is you do have to make sure that you account for all 16 possibilities. So right now we've accounted for this one and this one. Now the one don't care, don't care, don't care, that accounts for 1 0 0 0, 1 0 0 1, 1 0 1 0, 1 0 1 1, 1 1 0 0, 1 1 0 1, 1 1 1 0, and 1 1 1 1. So that one accounts for 8 all by itself. And we've got the 0 0 0 that one's accounted for. So we have these left that we need to take care of. 0 1 1 1, 0 1 1 0, 0100, 0011, 0010, 0001,
0101.
0101, 0, that's it. And that's 16. So those are the 16 states. So we need to decide what to do with those. And I suspect we can do the same thing with those 4. What do those 4 have in common?
Floor 1 is active.
Yeah. So what do we want to do with those?
Go to floor 1 door open.
I think so. So that would be do you want to go to this one or to the second clock cycle?
I'm not sure.
Yeah, I don't know.
Would it matter?
It doesn't matter. You just have to know so that when you're demonstrating it, you know if you have to go through another clock cycle or not before you can go somewhere.
I would think go back with the door open.
Everybody like that? Okay. So that would be, we would have a 0 and a don't care and a don't care and a 1. Okay, so the only ones we have left now are 0, 1, 0, 0, 0, 1, 0, and 0, 1, 0, 0.
Wouldn't they all go to floor 2 door open?
What about the one where you only have selected floor 3? Does the door need to open on floor? No.
Door closed?
Yeah. So these will go, so this would be 0, 1, 1, 0, and 0, 0, 1, 0. And then we'll also have this one, which was 0, 1, 0, 0. Okay, so then we need, as we were discussing, we're going to need a floor 2 door open, second clock cycle. And a floor 3 door open, second clock cycle.
I just have a question.
Mhm.
So like how on a, like in Verilog, do you account for 2 inputs on like the same direction going there? Without it choosing one or the other?
So it's in a case statement, and so you'll have you'll have all your possibilities, and what you do with each case is separate. So the real question that you mean to ask is, how do I account for these don't cares in the case statement without writing them all out? And I'll show you that later.
Okay.
Yeah. Okay, so I think that y'all have come up with a better design than last year's. Because the way I'm looking at it is I feel like these 9 states may be enough. And I think last time we had 11 or 12 or 13, because we did have a different one here, but I'm not sure we need one there. Because let's think about it. If you're in floor 1 and you select floor 3, the next clock cycle you'll be on floor 2 with the door closed, but you'll still have floor 3 selected. So if you're on floor 2 with the door closed and floor 3 is the only thing selected, you'll go to floor 3. You don't need to remember that you came from floor 1 to do that. Do you? I don't think so, yeah.
Also, if you're able to turn off floor 3 when you get to floor 2, then the don't cares would not matter.
Right. And then that way you could, right.
So how do you implement that? Is like going from floor 2 to floor 3 without having another input going, or you just mean like do another clock cycle again and just keep it going there?
Well, if you're on floor 2 with the door closed and the person suddenly decides, no, I want to go to floor 2, and they press the floor 2, why couldn't they?
Right.
I guess that's the way I'm thinking. They could just go to floor 2, door open.
Yes.
Because you wouldn't force them, say no, I think, but like I said, there was someone last year or last semester who really accounted for every possibility, including getting stuck between floors and everything, but I don't know that that's necessary. So, why don't y'all spend a minute and see if you can figure out what your next states would be for floor 2 door closed. So y'all do that on your own, and then we'll come back and talk about it, and we might not have all done the same thing, and that's okay. So just figure out what your next states would be for floor 2 door closed, accounting for all 16 possible different inputs. Each don't care that you have in your string accounts for 2 times as many states, because like don't care 001, that accounts for 0001 and 1001. If I put another don't care in there, that's going to double that number of states. It's going to account for 4 states. And if I put 3 don't cares in there, that'll account for 8 states. And so you can keep track of have you accounted for all the states by, if you have no don't cares, that accounts for 1 state, 1 don't care accounts for 2, 2 accounts for 4, and 3 accounts for 8. And see if we came up with similar sorts of things. So anybody want to share what they came up with?
You had those 3 don't cares going to floor 2 door open.
So first of all, I decided, since y'all had said that in floor 1 with door closed, if door blocked, we made that a don't care. I decided y'all would say the same thing with floor 2. And so I just said that the door blocked was a don't care for all of them. And then for if they selected floor 2, that we would automatically go to floor 2 door open. If we're on floor 2 already and they select floor 2, it makes sense, I think, to go ahead and go to floor 2 door open regardless of what else is set. And so, and that's what you just said, was here you said if they had floor 2 selected, you went to floor 2 door open. Okay, what else?
Don't care 100 went to floor 3 door open.
Okay. So if they had floor 3 selected, but not floor 1 or 2. You went to floor 3, door open. That's the way I would do it. What if you had no floors selected?
Stay the same? Or, yeah.
So don't care 0, 0, 0. So we have 2 more states to account for. We have don't care 1, 0, 1 and don't care 0, 0, 1. This one's easiest. What do you do if only floor 1 is selected?
Floor 1 door open.
Floor 1 door open. So don't care 0, 0, 1. Okay, so what are we going to do if we're on floor 2 and floor 1 and 3 are both selected? There's not an answer. It doesn't tell you one way or the other.
Do we just hard code it to go to one specific floor?
You can do that.
I think go to 3, complete the cycle. Because if you're coming,
We don't know that we're coming from 1 though. That is the way we have it set here. But we haven't, if we just have these 9 states, there are going to be other ways to get here. We could have this, if we did have this state set as you could only get here coming from floor 1, then it would definitely make sense to go to floor 3. But we don't have that set. You could do that. I would, for right now, let's just say we'll go to floor 3. And if we change our minds on that later, we can change our minds on that later. Okay, so that gives you an idea as to how to get this part set up. Now, I will on Wednesday and Monday go into more details about the code, but let me show you a little bit. See if I can find one. This is not going to be exactly the same as y'all's, so you do not want to just copy this code, but it will show you the basic idea of the next things that you're going to do is you're going to set up parameters for your different states. Yeah, see, there was an error state last time. And then they were using LEDs, so that's why we have these outputs for LEDs. So you can see it was a different project, but the same idea is you're going to be always at current state, and then to take into account of don't cares, rather than using case, you use case X. And then where we have these D's, you'll put X's. And so you'll just have all your different possibilities. So you'll have your different states and your different inputs. And then looks like this you have another always block for your outputs. And then your last always block to go to your next state. just to give you an idea of the basic structure. And that's gonna be the same as what we're gonna do. All right, so that's gonna be as far as I get for today. And then on Wednesday, I'm gonna do some work for the homework, and then continue on this some more. And if you have questions, feel free to email me. And if you want to get started on writing it, you should do that. And get enough if you want to, whenever you want to test it, you can get in touch with me, and I can be available. You can come test it and try it out.